Okay, so we're looking at sketching exponential graphs, and your basic graph is y equals a to the power of x. Domain is R and the range is R plus, and the shape of the graph looks like this. Looks to me like a plane taking off from the side. The horizontal asymptote is the x-axis, which is given the equation y equals 0. So when you sketch, make sure you put in your asymptotes. Your y-intercept is 0, 1, which we put in here, 0, 1. And the reason for that is when you make x equals 0, then y equals a to the power of 0, and as you know, anything to the power of 0 is 1. So therefore you have 0, 1 as the basic y-intercept. Okay, so when we're comparing bases, these numbers here, remembering that e is between 2 and 3, it's 2.71 something or other, you can see that we start with a small base, which we draw like so, about there. It's quite gentle to go upwards. And then if we do the medium base, which is e over here, then we would have something that goes a little bit steeper, but not by much. And then last but not least, the largest base, 10, we would draw as a very, very steep curve, which basically looks something like that. And as you can see, hopefully, that they all still cross at 0, 1. And that's because anything to the power of 0 is still 1. So 2 to the power of 0 is 1, e to the 0 is 1, and 10 to the power of 0 is also 1. So let's look at transformations of exponential graphs. This is similar to what you've seen before, where the number in front gives you the vertical dilation factor. And indeed, if we were to draw a rough sketch over here, technically we don't really need the y-axis, but you and me, we would have, if capital A was a positive, you'd have the basic shape taking off like that. And if A was negative, you would have a vertical reflection, also known as a reflection about the x-axis. So you're pretending that the x-axis is the mirror line here. That's a bit of a wonky line, but hopefully that's okay. Little a is just the base, and 1 on n is the horizontal dilation factor, which is basically the squashing in the horizontal direction. The main thing to remember is if n is negative, then it means it's a reflection about the y-axis. So if we have a basic graph here, and we had a positive n value, like this, then the negative n value would have the reflection about this line, which would be that shape there. H is still the horizontal translation, and again that's a minus h, which gives you a shift that way to the positive x direction. And K is the vertical translation, and it's the same sign, so it would be in the positive y direction. Okay, the domain is always R unless we've restricted the x values. Now the range is going to be above k, which we write as bracket k, comma infinity. We don't include the k because it's an asymptote, if a is positive. And you could also have a shape looking like this, and that would still work as well. The range is downwards from k, which we write as negative infinity to k, with the brackets around there, if a is negative. In other words, we had maybe a shape like this, or perhaps a shape like that. Can you see that the y values start at negative infinity and go all the way up to k? And y equals k is the horizontal asymptote. So here are the steps to sketch the graph of an exponential function. You look at the transformations first to roughly sketch the shape without putting any details in. You find the y-intercepts because there's always going to be 1, and you find the x-intercept if there is one. So here's one example. We have to sketch the graph of y equals 2 take away 2 to the power of x minus 1. We compare it to the general form, as always, to get a rough shape. And to do that, it's easier to move this term to the front and shove that to the back, which means that you have a negative 2x to the power of, negative 2 to the power of x minus 1, and then plus 2 because that's still a positive 2 over here. So if you look at it in steps, a is negative 1, which means that it's a reflection. And if our basic shape is like this, then what we're actually going to end up is that shape there. The base is 2, this number here, and we don't really think about that too much when we're sketching. The horizontal reflection, well, it would be the number in front of the x. In this case, it's 1. Let's put these letters in. A equals 2. So if the n equals 1, then the horizontal reflection is, well, it doesn't actually have 1. So there is no horizontal reflection. However, the horizontal translation will be something. You can see that that's just going to be 1 unit to the right, which I draw like this, and we would say translation of 1 unit in the positive x direction. And last but not least, k would be 2, which gives you the vertical translation upwards 2, which we would say is a translation of 2 units in the positive y direction. So that means what I have is an asymptote at y equals 2. I know the shape's going to be something like this, and I also know, hopefully, that if y is 2 is the asymptote, then this line, or the exponential graph, has to cross the x-axis somewhere. So I definitely will have an x-intercept, and always have a y-intercept. Now from this rough sketch, we can hopefully see that the asymptote, which is the easiest thing, is y equals 2. So we can write that in here. The domain is R, because all of the x values would travel along the x-axis. And you can hopefully see that the y values start at negative infinity and go all the way up to 2. So what we write is negative infinity, comma 2 as the range. So to find the y-intercept, we have to let x equal 0 and evaluate y. So let's substitute for x with a 0. So I have 0 here, and everything else stays the same. Y equals negative 2 to the power of 0 minus 1 plus 2. Now we have negative 2 to the power of negative 1 plus 2, which is negative a half. If you remember your first, I think it's the 5th index law, that means you flip it over and you make it 1 over 2. And then you have plus 2. So your final answer is y equals negative half plus 2, which is the same as negative a half plus 4 halves, which gives you positive 3 on 2. So therefore your y-intercept is 0 and 3 over 2. Sometimes you write it as 0 and 1.5, that's okay. To find the x-intercept, we let y equals 0 this time. So you would make y equals 0, and everything else you write the same way. Minus x, 2, to the power of x minus 1 plus 2. And this time I'll choose to move that across to make everything positive, to keep things simple. So we'd say 2 to the power of x minus 1 equals 2. And we rewrite this as a power. So 2 to the power of 1 is 2, just to make it really clear. And then because the bases are the same, then we can evaluate the powers, equate the powers, sorry. So you have x minus 1 equal 1. And then we move this across here, so we have to add 1 to both sides, which means you get x equals 2. So therefore our x-intercept is 2, 0. So let's put it all together. What we had before was a rough sketch from before with a asymptote of y equals 2. We've now worked out our y-intercept, which is 0, 1.5, and an x-intercept of 2, 0. So our first part is to sketch axes and put in the asymptote with the label y equals 2. Now ultimately I am going to sketch something that looks like this, but let's put in the y-intercepts and the x-intercept. So if I've used a scale, it doesn't have to be perfect, but it has to be reasonably to scale. So if that dot is where y equals 1, then my y-intercept needs to be right here, and we can label that with 0, 1.5. And for the x-intercept, you would have 2, 0. Now you've got a little more freedom because you haven't actually done anything else with the x-intercept. So I like to put it in a roughly similar scale if I can. So I've got 2, 0. And the last step is a little bit of join the dots. So hopefully I'll join the dots accurately and not miss the dots. Look at that. There you go, that's the final sketch. Just a little heads up, make sure you label the coordinates, not just the 1.5 on there. Coordinates are 2 numbers, not just 1. It's a costly mistake to you if you don't label them.